work power energy. In this chapter, we are going to learn about the concepts like work, power and energy. Introduction. Let us start with the concept called work. Here, observe these two examples. The first example is a man sitting on a computer and work for 12 hours a day. Similarly, the second example is a man carrying a heavy load on his head and standing under the sun for hours together. So, in these two examples, there is no displacement for the man. According to physics, the work is the measure of energy transfer that occurs when an object is moved over a distance by an external force. Due to the application of external force, body should displace. Then only work is said to be done. At least some part of this applied force is in the direction of displacement. So, here in the following two examples, can you say they are doing work? Generally, in the first example or in the second example, in first example, a person sitting in front of the computer and he is doing work for 12 hours means, normally we say some work has done there. They work hard. In the second example also, in the sun, the person stands for some hours of time. So, there also some work has to done. That means we said some work done there. But in these two examples, according to physics, the work done is zero. Because for the two examples, there is no displacement. But you can say they are doing work in terms of physics? No. Why? Because here, only when displacement is there, then only work is done. Why? Because there was no displacement in the above two cases according to physics. So now, what is work according to physics? Work is said to be done by a force when a body undergoes displacement parallel to the line of action of force. Along the line of the action of the force, if the body displaces, then we said work is said to be done by a force. So this is the statement of work done. Now, here, actually, man is on work, but according to physics, here work done by this man is zero. Why? Because no displacement. This is not work according to physics. But in the second example, here man pushes some object in the forward direction. Work is there here. Example is this one. Man displaces the object. Means he applied force along this direction, same direction body is moving. Displacement is there. We said work is done in this case. In this case, the work is done. Now, definition of work. Already we know, along the direction of application of the force, body displaces, work is said to be done by that force. Work is said to be done by a force when body undergoes a displacement parallel to the line of action of force or parallel to one of the components of force applied. Let us discuss in detail. Work done equal to, what is work done? Force and displacement. These two product gives work done. Work done is force into displacement. W is equal to force represented with F, displacement with S, then F bar dot S bar. F bar, force is a vector. S bar, displacement is a vector. Their dot product gives work done. Means here work done is a scalar. Dot product of two vectors gives scalar. Work done is a scalar. So W equal to F bar dot S bar. For example, here F bar act along this direction. Some external force act on this object along this direction. And the body displaces from here to here. What is the displacement of the body? Yes, S bar. Along which direction it displaces? This arrow mark indicates the direction of this displacement. Now, this F makes a certain angle with the horizontal or the displacement line. Then this F resolved into two components. Along this direction, for this theta, this line is adjacent side. Adjacent means cos component will come. For F, along this direction, F cos theta. For F, opposite to theta, this side is the opposite side. Opposite side means sine component will come. For this F, along the vertical direction, F sin theta is one of the rectangular component. This is vertical component. And F cos theta is the horizontal component. Observe here, F cos theta is directed along the direction of displacement. Let a constant force F bar applied on a body, this is that body, such that it makes an angle theta with the horizontal and body displacement through a distance S. How much displacement is caused in the body? That is S. Displacement is a vector S bar. For F, F cos theta is the horizontal component, F sin theta is the vertical component. So here, which component we are considering? According to definition, the component of the force which is parallel to displacement. In these two components, F cos theta and F sin theta. In these two, F cos theta force component is parallel to displacement. So, here F cos theta is in the direction of displacement of the body and F sin theta is the one of the component of force which act perpendicular to the displacement direction. Then, what is the force? Since body is being displaced in a direction of F cos theta, work done by the force is displacing the body through a distance S is given by now formula. W is equal to, what is the formula? F into displacement, force into displacement. What is the force here? F cos theta we consider. Why? Because along F cos theta direction only displacement is there. There is no displacement for this body along the vertical direction. Only along the horizontal direction means F cos theta acting direction only body displaces. Hence, W is equal to force component along the displacement, that is F cos theta into S. F cos theta into S. W is equal to F S cos theta. F is vector, S is vector. Cos theta, cos of angle between these two vectors, means work done is dot product of F bar and S bar. Work done is dot product of F bar and S bar. Thus, work done by a force is equal to the scalar product or dot product of the force and displacement of the body. This one. Now, work is a scalar quantity. CGS unit of work. What is formula for work? W equal to F into S. F is force, S is displacement. F. CGS unit of force is dyne. Displacement CGS unit is centimeter. Means CGS unit of work done is force dyne, displacement centimeter. Dyne centimeter is CGS unit of work. We called this dyne centimeter as arc. The CGS unit of work is arc. Similarly, then SI unit of work is Newton meter, which is we called as joule, represented with J. Now, 1 joule is nothing but 1 Newton into 1 meter. 1 Newton force is applied on the body, causes a displacement of 1 meter. Then 1 joule of work is said to be done on that body due to that 1 Newton force, which is equal to 1 joule value is, we convert it into X. How? 1 Newton. What is 1 Newton value in dyne? 1 Newton equal to 10 power 5 dyne into 1 meter. 1 meter value converts into centimeter. 1 meter is 100 centimeter. 100 is nothing but 10 power 2 centimeter. 10 power 2, 10 power 5 means 10 power 7. 1 joule equal to 10 power 7. What left? Dyne centimeter. Dyne centimeter gives arc. Means 1 joule is equal to 10 power 7 dyne centimeter. Also called 1 joule equal to 10 power 7 arc. MCQs. The work done in holding 15 kg suitcase while waiting for a bus for 15 minutes is. Here you are holding an object but no displacement. Here weight of this object act downward but there is no displacement in this case. So work done is 0. Options are these 4. The correct option is 0 because there is no displacement. That's why work done is 0. Next question. A circular track of radius r is in a vertical plane. AB is a vertical diameter. The work done in moving a mass small m along the path ACB is, G is acceleration due to gravity. Let us observe this diagram. So in this circular path an object is moving. AB is the vertical diameter. Now an object is moved from here to B point through the path ACB. Then what is the amount of work done? The mass of the object is given as m. So here options are these 4. Now the correct option here is this one. Why? Because here force into displacement is the work done. What is the displacement? Displacement is the shortest distance between the initial and final points. Here initial point is A, final point is B. Then A to B, the shortest displacement is nothing but the diameter of this circle. So diameter of the circle means R is its radius. Then diameter is 2R. So what is the displacement of the body? A to B, it moves through the path ACB. Its displacement is 2R only. 2R is the displacement. S equal to 2R. What is the force? What is the weight of this object that acts as force? Weight means mg. F equal to mg. S equal to 2R. What is the work done? W equal to Fs. Fs means mg into 2R. 2 mgr is the explanation. Next. A force F equal to 5I plus 3J Newton is applied over a particle which displaces it from its origin to a point r bar equal to 2i cap minus 1j cap meters. The work done on the particle is, what is force applying? Applied force equal to 5i cap plus 3j cap in Newton. And origin to this point, the body displaces due to the application of this work. What is the final point? 2i minus 1j, unit vector form. Now, work done. Options are these. Now, what is the work done? W equal to F bar dot S bar. S bar is displacement. Origin means here to this point displaces. The displacement vector becomes 2i cap minus 1j cap. And F equal to 5i plus 3j cap. Then W equal to F bar dot S bar. Dot product of these two gives the work done. So 5i cap, here in case of S bar 2i cap. 5i dot 2i gives 10 plus into minus. Minus 10 minus 3 into 1. 3 into 1 3. 10 minus 3 7. So correct option is plus 7 joules. Next, types of work. How many types of work is there? So here, work done by a force may be positive, negative or 0. So, when do this work done becomes positive or negative, or it may 0? For that, first case. What is first case? Positive work. When do this work becomes positive? Here, positive work means the force is parallel to displacement. Why? Because formula is W equal to Fs cos theta. W is equal to Fs cos theta. Here, for theta value lie between 0 to 90. Means the force applied direction and displacement direction both will parallel to each other. In that case, the work done becomes positive. Means, observe here, along this direction displacement, applied force is along this direction up to the theta lie between these two limits. Theta lie between 0 and 90. In this case, work done becomes positive. First one. So, work done equal to W, which is Fs cos theta. If theta value lie between these, then work done is positive. Next, observe this animated picture. Along the direction of force applied, object is displacing. Object is displaced along the direction of force applied. Means when force and displacement parallel to each other. In this case, this theta becomes 0. Theta is equal to 0. When theta is 0, cos 0 is plus 1. Means work done becomes positive. So this is work done positive example. The positive work signifies that the external force favors the motion of the body. Why? Because displacement is along the direction of force itself. So, it favors the motion of the body. Now, examples for positive work done. When a person lifts a body from the ground to some height, then the work done is positive. Like this. Why? Because force displacement. Force and displacement. This is force applied direction. Displacement direction. Both are parallel to each other. What is work done formula? W equal to F bar dot S bar, which is equal to Fs cos theta. What is theta here? Both are parallel means theta equal to 0. Cos 0 is 1. means W equal to Fs. Means work done is positive. One of the example is this one. Next example. So here animated picture you observe. This person lifts some weight from ground to certain height. In this case, displacement is an upward direction. Force, how much force you have to apply? At least equal to lifting weight. So that applied force upward direction, and displacement is also in upward direction. So the first case is this one. Second example for positive work. When a spring is stretched, work done by the external force is positive. Observe that one. You are stretching the spring by fixing its one end to some rigid support. On the second end, we apply some force. The force direction and displacement direction both are along the same direction. So again in this case, theta is equal to 0. Theta equal to 0, here also work done is positive. This is the animated picture of force applied direction. Force applying direction, displacement direction, both are parallel. So in this case, the work done is positive. So these two are the examples for positive work done. If the displacement is in the same direction of the force, then work done is maximum. Why? Because theta is 0 degrees. Then W equal to Fs cos theta is the formula. Theta is 0. W equal to Fs. Just product of the magnitude of the force and displacement gives the work done. So this is the about positive work done. The second case is negative work done. So what is negative work done? Work done is negative means that force is opposite to the direction of displacement. W equal to F bar dot S bar is equal to Fs cos theta. That is the formula for work done. If theta is 180 degrees, then cos 180 is minus 1. Work done equal to Fs cos 180. Cos 180 is minus 1 means W equal to minus Fs means work done becomes negative. So corresponding explanation are these. If theta is the angle between the force and displacement, if this theta value lie between 90 and 180, that is in second coordinate, then work done is negative. The negative work signifies that the external force opposes the motion of the body. Examples for negative work. When a person lifts a body from the ground, the work done by the force of gravity is negative. Let us observe this diagram. Here, the person lifting the weight from the ground. Here, displacement is in upward direction. Work done by the gravity, force of gravity. Force of gravity means weight of this object. Always weight of the object directed towards the ground. Downward means force direction is downward. Displacement in upward direction. How these two are? These two are opposite in direction. This F is the weight of the object which act downward. Why? Because here work done by the force of gravity. That's why this F is equal to weight of this lifting object which acts directed downward. And displacement. Both are opposite means angle between F and S is 180. If theta is 180, W equal to Fs cos 180 which is equal to minus Fs. Why? Because cos 180 equal to minus 1. So this is one of the example of negative work done. Second example. When a body is made to slide over a rough surface, the work done by the friction is negative. Why? Because here the applied force direction is along this direction. Applied force direction is along this direction. But here always friction is acting in a direction opposite to the tendency of motion or relative motion. means this arrow mark direction gives frictional force direction, but the body displacement along this direction. Here work done by the friction means force is Fs, static friction mentioned, and displacement is S bar. This Fs direction and S bar direction both are opposite to each other. Again, angle between Fs and S bar both are anti-parallel. Anti-parallel means angle between them is 180. The angle is 180, work done becomes negative. So these are the two examples where work done becomes negative. This one. Next one. If the displacement is opposite to the direction of the force, then work done is minimum. Why? Because theta is 180, cos 180 is -1. So work done is negative. W equal to Fs cos theta. What is theta now? 180. Cos 180 -1. So minus Fs. W is negative of product of magnitudes of force and displacement. That gives work done. So that is negative work when theta is 180. Means that work done is minimum work done. Next case. Zero work. When we say the work done is 0. Here force applied direction, displacement. These are perpendicular to each other. Let us consider. Displacement, force applied direction. Means angle between F and S is 90 degrees. Cos 90 is 0. Simply we said work done is 0. Hence, under three conditions, work done becomes 0. In that three, just now explained one condition. If force applied and displacement, these two are perpendicular to each other. That is case 1. Force applied and displacement both are perpendicular to each other. If the force is applied perpendicular to the displacement, force is perpendicular to the displacement, that condition is work done is 0. W equal to Fs cos angle is what? 90. It is 90, then work done becomes cos 90 is 0 implies W equal to Fs into 0, which is equal to 0. Second condition, example for that. Listen here. When a body moves in a circle, the work done by the centripetal force is always 0. Like this. Here, in this example, centripetal force direction is always toward the center. This is the center of the circle, that is O. Along this direction, centripetal force is directed. And displacement, at this point it moves like this. This is the motion of the circular object in the circular path. This is the motion of the object in the circular path. At this point, displacement direction is this one. This displacement direction, centripetal force, both are perpendicular to each other. Theta is 90. Again, work done becomes 0. Next, second condition. If there is no displacement on an object, even though we are applying some force, that body will not displace it. Then the work done is said to be 0. S0, W equal to Fs cos theta. S0 means the total product is equal to 0. Example. When a person tries to displace a wall by applying a force, and if it does not move, the work done by him is 0. Observe this one. The person pushes the wall. He tries to displace the wall by applying some force, but there is no displacement in this wall. Then the work done by him is said to be 0. This is example for no displacement case. No displacement, work done is also 0. Third case. What is third case under which work done is 0? Work done becomes 0 under the case where F is 0. No force is acting. So, if angle between F and S is 90, means applied force, displacement both are perpendicular to each other, we said no work done. Second case, if displacement is 0, we said no work done. Third case, force acting is 0, we said no work done. Example. If the body is moving with uniform velocity on a horizontal frictionless surface, what happens here? Uniform velocity means acceleration becomes 0. If acceleration is 0, applied force also 0. F equal to ma, Newton's second law, F equal to ma, which becomes 0. Why? Because a is 0. So F 0, then the work done becomes 0. On a frictionless surface, even there is no frictional force also. On a smooth horizontal surface, a body moves with uniform velocity. Then, uniform velocity, acceleration 0. Acceleration 0, F equal to ma, means force is also 0. Then, we said no work done on that body. 0. So, these are the three conditions under which work done is positive, work done is negative, work done is 0. A man pushes a wall and fails to displace it. He does work, negative work, positive work, but not maximum work. Maximum work, no work at all. The fourth option is correct. Option D is correct. Why? Because wall doesn't have any displacement. There is no displacement in the wall. That's why the work done is 0. No work at all. This one. Next question. A man is rowing a boat upstream, and in spite of that, the boat is found to be not moving with respect to the bank. The work done by the man is 0, positive, negative, maybe positive or negative. The work done is positive. Next question. A laborer carrying a suitcase on his head, starting from rest, walks on a horizontal road to another point and finally come to rest. He does work. That work is called as maximum work, positive work, negative work, 0 work. The options are maximum work, positive work, negative work, 0 work. Positive work. Why? Because initial to final point, there is some displacement along the direction of displacement. There is some work done